we have 27%. That'll be 27 out of 100. Of 60, remember we read that as out of 60, implies the 60 goes on bottom. So we're going to cross multiply and divide. So we find the two numbers that are diagonal. The 27 and the 60 are going to get multiplied. Then the 100 is diagonal to our missing number, so we divide by the 100. 27 times 60 divided by 100 gives us 16.2. So 16.2 is 27% of 60. For the second one, 15% of, or 18 is 15% of blank. So 15% is 15 over 100. Now here the 18 is 15%. That implies the 18 goes on top with the 15. Of blank, read again out of blank, implies that missing number goes on bottom. So again, we multiply the things that are diagonal. Those are the 100 and the 18. So we do 100 times 18, giving us 1800. The 15 is diagonal with our missing number, so we're going to divide by the 15. So 1800 divided by 15 is 120. So 18 is 15% of 120. Then for number 3 down here, 45 is blank percent of 50. So we're missing the percent. So we'll do blank over 100. 45 is blank percent. That implies the 45 goes with that missing percent. Of 50, again, we read that as out of 50, implies the 50 goes on bottom. And again, we look for the two numbers that are diagonal. It's the 100 and the 45. So we multiply those. 100 times 45 is 4,500. And then the 50 is diagonal to our missing number, so we divide by 50. That gives us 90. 90 out of 100, or 90%. 45 is 90% of 50. Now, 4 and 5 were what we referred to as our percent increase or decrease problems. Number 4 is a discount of 7%. After that discount, Pat pays $483.60 for supplies. In these types of problems, we have to be very careful to define what the base amount is. The $483.60 is not the base amount. That's the amount after the discount. The base amount was the amount before the discount. The 7% here only indirectly applies to that $483.60. Remember, the full price was 100%. We subtract that 7% to get 93% is what applies to the price after the discount. So 93%, or 93 out of 100, the $483.60 represents the 93%, the price after the discount. So now we'll cross multiply and divide. The 100 is diagonal to the 483.60. So we multiply those, and then we divide by 93. Giving us $520 was the original price before the discount. That's our base amount. Now we have to make sure we've answered the question. The question here is, how much was Pat's discount? So to find that, we go back to that original price, the $520. We subtract what Pat paid, $483.60, and we are going to get, what, $36.40. That is the amount of Pat's discount. So when it's a percent decrease, a lot of times we have to be aware of the percent of the discount or the decrease can be subtracted from 100 to find the percent of the final amount. And if it's that final amount that we're given, we have to make sure we work with that percent rather than 100%. Number 5 is very similar. This is a service charge, so this is a percent increase. So remember, we have 100% plus an 11% increase. means we're dealing with something that is 111%. After that 11% service fee, Sam pays $688.20 for supplies. What was the cost of supplies before the service fee? So we're dealing with 111%, or 111 out of 100. The $688 is the cost after that fee. So that's the 111%. $688.20. So again, we're going to cross multiply. We'll multiply the two numbers that are diagonal, and we'll divide by the number that's diagonal to our missing number. So 100 times 688.20 divided by 111 gives us $620. So that is the price before the service fee. We go up, and that actually was what we were asked to find, was the cost of supplies before the service fee. So $620 is what we're looking for there. Anybody have any questions on those? How about any questions off the homework from last Thursday? Okay, well, there is a new quiz in Blackboard. I believe it is quiz 5. That is going to be due by noon tomorrow. So that's noon, September 23rd. So make sure you complete that. That'll be our last quiz of Unit 2. Remember, Thursday of this week is Unit 2 test. So that means on Thursday I will be logged into class, but the test is out there in Blackboard for you to download and take, as long as you do it sometime during the day on Thursday. Like I said, I'll be in online during class time to answer questions if you want it. If nobody shows up within the first 20 minutes or so, I'll probably duck out too. But there won't be any lecture on Thursday. It'll just be the whole class time will be dedicated to taking that test. So as long as you get it done sometime during the day Thursday, you don't have to be in class on Thursday. Okay then, let's start with our new material. Well, we're going to build off of that idea of a percent increase today. We're going to look at, and we're also going to go back to looking at that rate method. We're going to use one of the most common applications of the rate method, and that is interest. We said that rate method applies when we know the base amount and a percent. We just turn that percent into a rate or a decimal and we multiply it out. So let's say that we have an amount we'll call it a principal amount. That's the starting amount for an investment of $8,000. And we're going to earn 3% interest. The amount of interest is going to be that base amount, the $8,000, times 3%, but as a rate, as a decimal, 0.03, which gives us $240 in interest. Now, there's a flaw in this little statement here. Actually, this is the math is correct, but the flaw is that this is just exactly one period. So in order to account for the fact that the time frame may not be a full period of time, we have a formula for simple interest. Now, first, a little bit of a word on what simple interest is. Simple interest is really the simplest way there is to calculate interest. That's why it's called that. In simple interest, interest is only calculated if it's the end of the term. If it's a 2-year investment, at the end of 2 years, you'd calculate the interest. A 6-month investment. At the end of 6 months, you'd calculate the interest. Or 2, if there's an action on the account. Now, by an action, I mean money is deposited into the account or taken out of the account, or if it's a loan, a payment is made or a withdrawal is made. Before that money is taken in or out, the interest is calculated and added in so that we don't have to worry about, balancing it out for the changing amount during the period of time. A lot of people don't realize that many of the loans you take are actually simple interest. Almost all of your auto loans are actually simple interest. Well, you might think, well, they're not waiting till the end of my 5 years to calculate interest. No, they're not. But they expect you every month to make a payment. That is an action on the account. They calculate the interest when you make the payment. So if you make the payment late one month, you might have a larger interest charge because there's more days that have gone by. Or if you make your payment early one month, you might get a smaller interest charge because of that. So let's look at that formula for simple interest that accounts for, like we said, accounts for the time frame. That formula is the amount of interest, I, equals the principal, times the rate, times the time. So what we did up above here, that was just the principal times the rate. We were assuming that the time period worked out. So I here is the dollar amount of interest. P is what's referred to as a principal. That's the starting amount. R is the rate. Remember, that is the decimal form of a percent. And T stands for time, but it's always given in years. So let's say we want to invest $4,000 at 8% simple interest for 3 years. The amount of interest earned here, I, is going to equal our principal of $4,000 times our rate. 8% as a decimal is 0.08 times our time of 3 years. That comes out to be $960. Now the next thing we need to look at is something called maturity value. Maturity value is how much is it worth at the end of the period. Well, the maturity value is simply the principal plus the dollar amount of that interest. So for this problem here, we have our principal of $4,000 plus the $960 we earned in the interest over that 3 years, giving us a maturity value, $4,960. Now, for this example I did here, it was 3 years long. Banks do not like doing simple interest for 3 years. On your car loan for 5 or 6 years, that's different because you have to make a payment every month. So the interest is going to get calculated when that action is made. But if it's just a savings account or a single payment loan, they don't want it sitting there for 3 years without the interest being calculated in. They want to be able to update their books regularly so they know how much interest they owe or how much interest is owed to them, so they don't have these big piles of interest coming due at the end of these terms. They want to figure it out slowly over time. So typically, simple interest is not used for anything longer than 6 months at the most, but for many banks, 3 months is the longest they'll go with simple interest. So let's look at a more reasonable example. Let's say we're going to invest $2,000 at, we'll go 1.8% simple interest for 4 months. So to find the dollar amount of interest here, The principal is $2,000. 1.8% as a rate is 0.018. Now, 4 months. Remember we said our time was always expressed in years. So to express 4 months as years, well, there's 12 months in a year, so that's just going to be 4/12. Yes, I know you could reduce that to 1/3, but it really doesn't have to be done. So now 2,000 times 0.018. To enter the 4/12, I don't have to enter it as a fraction. I just do times 4 divided by 12. It gives me $12 in interest. So that means my maturity value would be the $2,000 plus the $12 in interest, or $2,012 after those 4 months. So that's simple interest and how simple interest works. Next, let's take a look at what happens in those longer investments with something called compound interest. Compound interest is called that because every so often they calculate the interest, add it into your account, and then the next period you get interest on top of that previous interest. It compounds. So that's where the term comes from. For compound interest, usually they go sometimes monthly, sometimes annually, quarterly, semi-annually. Let's go back to our previous example where we invested that $4,000 at 8%. But before it was 8% simple interest, now we're going to say it's 8% compounded quarterly. And we're still going to go for 3 years, just like we did before. But when it was simple interest, we could do the interest calculation all in one step, and it was done. Here we have to break it down by the quarter. I'm going to go with beginning balance here. So I calculate interest. Then we give an ending balance for each quarter. So in our first quarter, we start out with the $4,000. Our interest, 4,000 times 0.08, that's the 8% as a decimal. Quarterly, however, which means we're only going to go for 1/4 of a year. So that ends up being $80 in interest. So we add that on, our ending balance is $4,080 at the end of the year. That means we start the second quarter with a beginning balance of $4,080. So when we calculate the interest, it's not 4,000, it's 4,080 times 0.08 times the 1/4, which gives us $81.60 in interest for that year, or for that quarter, I should say, and an ending balance of $4,161.60. Well, to get to the end of 3 years, how many times am I going to have to do this calculation? Quarterly means 4 times a year for 3 years. That's 12 times. That's 12 quarters. I don't want to do this 12 times. So let's look for a shortcut. First thing I want to point out is this right here. Each quarter, our interest was 0.08, or the rate, I guess you should say, is 0.08 times 1/4, which comes out to 0.02. That's 2% per quarter, which makes sense. If a quarter is 1/4 of a year, if it's 8% for a whole year, a quarter of that, or a fourth of that, would be 2% for a quarter. That makes sense. And if we look at quarter one, we started out with $4,000. We added the interest of $80 to get $4,080 for our ending balance. Well, this is our beginning balance plus our interest, get our ending balance. if we think of our beginning balance as being 100%, the interest we said was 2% for a quarter, the ending balance should have been 102%. Well, let's test that out and see if it works. If I take my beginning balance of $4,000 and I multiply by 102%, as a rate that's 1.02, I do get 4,080. For the second year, if I take that 4,080 times 1.02 again, I will get the correct ending balance of $4,161.60. So it works out. Now I still have to do this 12 times. In math, however, if I'm going to multiply by the same thing over and over again, we have a shortcut for doing that. So we're going to take our beginning balance of $4,000 times 1.02 to the power of 12. That power of 12 is saying we're going to multiply by the 1.02 12 times. So 4,000 times 1.02, that's 102%, the power of 12, gives us $5,072.97. Compare that to what we had from simple interest, which was $4,960.00. That's a significant gain. That's almost $113 difference for having compound interest. Now, this next little piece I'm going to show you, I feel is the most important part of the course. It has very little to do with what program you're in. It has everything to do to planning your life once you're out of school. A show of hands, how many of you are under 20 years of age? Okay, a good share of you are. Good. So that makes this a little more impactful for you. So let's say you get out of school and you're going to be 22 years old. Some of you might be 20 years old when you get done with school. Let's say you get that, right now you're in school, you tend to be living cheaply, whether you're living in a cheap apartment with roommates, driving your older car, maybe even living with parents to save money. You're living cheaply because you need the time to go to school, so you can't work as much as you would like to pay your bills, or you have to pay for the cost of school. Either way, you're living fairly conservatively at the moment. Well, a lot of students, they get done school at 20 or 22 years of age, they get that first good job. They're getting a good paycheck. They want to, first of all, usually they want to move into a nicer apartment. And second, actually, sometimes the first thing they want to do is they want to get that nicer car, new truck or whatever. But what if you hold off for a couple of years? Even if it's just 1 year, you keep living the way you are. Keep driving that old car. Stay in the apartment with roommates. Live cheaply. I realize some of you are in the dorm apartments. You can't stay there, but you can still stay in a cheap apartment with roommates to save some money. It wouldn't be that much of a stretch to say you could put away $5,000 that first year. If you just kept living the way you are while you're in school and put away the extra money that you're earning rather than spending it. Right now, minimum retirement age is 67 years of age. Actually, for me, they've already said it's going to be like 68 and a half. For many of you, it'll be 69 or 70 years of age, somewhere in there. But let's just go with 67. That's 45 years that money is going to sit there if you put it in at age 22, if you save it at age 22. The average 45-year gain in the stock market right now is between 13 and 14%. That's per year. So let's be conservative. Let's say you can earn 12% gain. So that means at the end of every year, you're going to have 112% of what you started with. So 112% is 1.12. That's just compounded once a year. If it's 45 years, that's going to be the power of 45. If you let that $5,000 sit there and invest, now I'm not talking about a bank account. I'm talking about going to a good investment planner like a Fidelity, Prudential, Edward Jones, Allstate, some of those actual professional investment planners, and getting into mutual funds, corporate bonds, stuff like that. You'll get that interest rate. Let's take a look. 5,000 times 1.12 to the power of 45. This always blows me away. That one payment of $5,000 at age 22, at 67, is $819,938. So about $750,000 would be sitting there. If you just put that away at age 22 and gave it to a good investment planner, even if you played it conservatively, and you only got 10% on your rate. A lot of people say, well, I'll just get 10%. It's a little safer, and that 2% doesn't make a huge difference, does it? Well, it does. Let's take a look. So now the 1.10 is just a 10% gain. That's 110% at the end of each year. The power of 45. You still get 364,452. But that 2% difference cuts your result over 45 years to less than half. So think about that. If you're putting it in the bank at only earning 2 or 3% on it, you're losing out on a lot of potential return there. You drop down to 8%, that comes out to only about $150,000. 6%, you're coming to about $65,000. 4%, that $5,000 is only turning into about $30,000. So it makes a huge difference. At 2%, that $5,000 really only turns into about $13,000 or $14,000, which is a significant drop from what you could have gotten. This is if you do it at 22 years old. What if you get out of college and you decide, you know what, I'm young, I have a good job, I want to have some fun, I want that snowmobile or that four-wheeler, I want that new truck. So you spend your money for a few years and you get to be age 32. And now you decide, okay, now I'll put away some money for retirement. You put away that same $5,000, and let's go with just the 10%. So you can get the 10%. This is only going to be 35 years now, though, instead of 45. 5,000 times 1.10 to the power of 35. This is a significant decrease, about 140,512. Just over a third of the amount is what you would get. By putting it in 10 years earlier, you get almost 3 times the return on it. Well, let's say you really mess up and you have a lot of fun while you're young and you build up a lot of debts and you have to take 20 years or so to dig out of that hole. So now you're 42 years old and you finally decide, okay, now it's time to start saving for retirement. So you put away that $5,000. And let's assume you can still get 10%. But now it's only going to sit there for 25 years. A significant drop. You're going to get $54,174. So again, almost cut to a third of what you would have had. So compare these two. You invest just one payment of $5,000 at 22, it's over $350,000. If you wait till you're 42, it's only about $50,000. It's about 7 times as much if you invest it young. In fact, since we have a few minutes, I'm going to show you an example here, a couple of examples that I think are just hugely significant. So let's start out at a young age here. We'll have you start out at 21. we're going to go up to age 67 again. And let's just pick a number. Let's $5,000 a year. Well, let's say only $3,000 per year is what we're going to invest. I'm going to turn these into currency quick. Or maybe not quick. It's just taking it a while because of all the cells. There we go. And we're sticking a 10% gain here. So we're going to invest that $3,000 a year every year, starting at 21 until age 67. $3,000 a year is about $250 a month. That sounds like a lot of money. Really isn't that bad if you're living within your means. What's that balance going to be at age 67? Hold your breath. This is kind of significant. $2.5 million. I'm pretty sure we could all retire on $2.5 million. Now let's change some things here. This person, this first one I'm going to look at, did what I suggested. At 21, they put away the money, and they actually do it for a few years. They go from 21 to 28. Let's say they do it for 8 years. And after 8 years, they say, you know what? I'm not putting the money away anymore. I'm going to start playing with my money. So from 21 to 28, they saved. Starting at 29, so now I'm going to play with every penny I make for the rest of my life. So they're not going to put anything else away. When they retire, they still have almost $1.5 million. This other person over here decides to do it the other way. They say, I'm 21, I'm young, I want to play, I want a four-wheeler, I want a snowmobile, maybe a boat, new truck. So they don't save anything for those first 8 years. And they start at age 29. So this person over here put $3,000 away for 8 years. That's a total of $24,000. This person here started at 29, saved it every year for almost 40 years. Almost $120,000 put away. But look at their final balance. This person never caught up. That first 8 to 10 years of your life, once you're out of school, is worth more to your retirement than the rest of your working life is. I use this example a lot just because it really is significant. If you save, even if for 5 or 6 years after college, you put as much away as you can into retirement, you're done. You don't have to worry about saving for retirement after that. All you have to have is if you can get $10,000 into a retirement account by the time you're 25, you're going to have $750,000 in your retirement if you do it invested properly with a good investment planner and have them plan it out. That doesn't mean you should stop at that point, but it means you've got a little cushion. You've got it all done and you don't have to worry about it so much anymore. Anybody have any questions on that? Or any examples they'd like me to plug the numbers in to see how it turns out? Okay. Now the last formula, and this is one that it'll be in the homework, but I would never put it on a test or a quiz. Maybe an extra credit question. It's how do you calculate the amount of payment that's needed on a loan? Or let's say you're going to put away money every month, and how much is that going to build up to? Let's say you were going to do a monthly savings. So your monthly savings, let's say you're going to put away $100 a month at, let's say you're getting 6% interest on it, and you're going to do it for the next 20 years. What will you have at the end of that 20 years? Well, the formula is that future value is equal to your payment amount that you're paying in times, now I'm writing this formula in the form of what you would enter it in the calculator. So yes, there is 3 parentheses there. 1 plus our rate divided by n. N is the number of times per year. If it was quarterly, it would be 4. If it's monthly, it's 12. To the power of n times t, where t is your number of years, minus 1, close parentheses, divided by r divided by n again, and then close and close. So let's look at this. $100 a month times 3 open parentheses, 1 plus 6% is 0.06. That's per month, so it's divided by 12. To the power of, that's going to be 12 times 20, minus 1, close parentheses, divided by 0.06 divided by 12. Close and close. Let's put this in the calculator. $100 times 123, 1 plus 0.06 divided by 12, close parentheses, to the power of 12 times 20, close my parentheses, minus 1, close, divided by, open, 0.06 divided by 12, close and close. That comes out to $46,204.09. That is our balance at the end of 20 years, just putting away $100 a month. Now, the opposite formula for that is the payments on a loan. The amount of payment on a loan is equal to the principal divided by 3 open parentheses, 1 plus the rate divided by n. Again, n is the number of times in a year. The power of n times t, where t is your years, minus 1, close parentheses, divided by. Now, this next piece is a little different. R divided by n times, parentheses, 1 plus r divided by n to the power of n times t. So let's say you're going to get that $50,000 truck. You're going to borrow at, right now you can get an auto loan for right around 4%, 3.5%. If you have extremely good credit, you can get 2.9%. Let's go at 3%. Let's say you've got that pretty good credit. Let's go at 3% for 6 years. 6 years would be about the minimum they'd let you. I've seen auto loans now, 8 years I've seen commonly. I saw one up to 10 years here not too long ago, which to me is way too long to borrow for a car or a truck. So we got our $50,000 divided by 3 parentheses, 1 plus 0.03. You make your payments every month, so that's going to be divided by 12. The power of 12 times 6 minus 1. 0.03 divided by 12 times 1 plus 0.03 divided by 12. Power of 12 times 6 again, and close and close. Let's see what this payment is, a $50,000 truck. Now, $50,000 is not a very expensive truck anymore, by the way. 1 plus 0.03 divided by 12, close, to the power of 12 times 6 is 72, so I'm just going to save a couple of keystrokes to enter 72. Minus 1, close parentheses, divided by open parentheses, 0.03 divided by 12, times parentheses 1 plus 0.03 divided by 12. This formula is quite a mouthful, I admit that. You get $759.68 a month. Now, if I multiply that times 72 payments, you are paying $54,697 for that truck. That's not bad. Only $4,700 in interest on a truck. That's not horrible. I want to show you an example of the value of keeping your credit rating at a good rating. That 3% interest, that's assuming that you have like a 715 or a 720 credit rating or better. Let's say you did some things wrong. You ran up some credit cards, you defaulted, missed some payments. Let's say you're sitting down in that low 600s. I have seen auto loans. Actually, the worst one I saw is I had a student who came in, had a 24% auto loan. We're not going to figure that out here, but let's say you're at 9% for 6 years. So that formula is going to be the exact same, only we're going to put in 9% for our rate. So 1 plus 0.09 divided by 12 to the power of 12 times 6 minus 1. Let's punch this into the calculator just to get a payment. Again, I'm just going to do 12 times 6 is 72, so I'm just going to enter 72 there to save a little time. So your payment is going to go from $759 up to $901.28. Now let's multiply that times 72 payments for the 6 years to get a total amount paid. You're going to pay a total of $64,892.16. So you're going to go from paying $54,000, almost $55,000 for that truck to being almost $65,000 for that truck. Significant, very significant difference in the amount of interest paid there. Now, like I said, those last two formulas, the future value of savings formula, that was this one up here. That's if you put away monthly. You could change it for quarterly or annually. There'll be some problems in the homework about that, but you won't be tested or quizzed on it. I'll probably have some extra credit questions posted on it if you want to do the extra credit on them. Same with this one, finding the payment on a loan or what they call a sinking fund. If you had that money saved and you're drawing it out, how much you could draw every month. Again, that would be an extra credit question. But I do expect you to understand at least the basics of the compound interest and the simple interest. So your homework is going to be page 97, 1 through 13, the odds. So it's only going to be 7 problems for you. We've only got about 3 minutes left, so we'll cut her off there for you. I'll stay on the network for a couple of minutes if you have any questions you want to go over. Or